Happy, what day is this video? It's Friday today. I don't know what day you're watching the video. I think Tuesday. I don't really know. You guys had the Veterans Day Assembly on Monday. Hooray, I hope you guys had a good time with that. I'm not quite sure what's going on today. Guys, I'm a little out of it. If you notice, I'm in sweatpants and a t-shirt. More importantly, I'm also in sandals because I've changed recently at some point. I think. I showered though, so that's a plus. Eliana's doing well. She's sleeping throughout the day, which is wonderful throughout the day. Nighttime's a little bit different. So, yay for being a new parent again. But from what I've heard, you guys have been doing well, and I appreciate that. I hope that we're able to see this. I'm in Mrs. Armstrong's room because my room, you guys are doing stuff in there. So today we are doing two-step equations. Quick little review. Because you have a quiz this Friday on combining like terms, distributing one-step equations, two-step equations. So if I give you something that looks like 3x minus 5x, we can all simplify this. These are like terms. I've told you, hey, circle are like terms. So we know that if I'm dealing with x's, which are my xylophones, I keep the xylophones. Then I worry about 3 minus 5. Those are different signs. Absolute value is now 5 and 3. We subtract, which gives me the 2. The larger absolute value is the 5. So now I have negative 2x. And there is my simplification. Well, how can I use this in a two-step equation now? So, well, let's go back a little bit. Let's go back to a one-step. Let's say I have negative 5x equals 15. I taught you to go to the middle of the equation, the balance point, and we make an inverse operation line. So now we're here. I've got negative 5x's. We only want 1x. That's isolating the variable. So the inverse of negative 5 multiplied by x, because it's not adding 5, that's not what this is saying. It's saying negative 5 times x. When it's smacked out up against the x, it's multiplication. The inverse is division. So I'm dividing by 5. But if I divide by negative 5 on this side, I have to divide by negative 5 on this side because I'm moving it to the other side. That's why it's the inverse. Negative divided by a negative is positive. 5 divided by 5 is 1. So I could really have 1x because that's isolated. But really, it's just an x. X equals 15 divided by negative 5 is negative 3. That's solving one-step equations. You've done that a couple times. We are going to see today two different types of two-step equations. The first one will be using combining like terms on the same side. So when I look at 3x minus 5x equals 12, the first step does not change. I find my balance point. I make my inverse operation line. And now, let's see if I can find a piece of paper. I'm only going to worry about one side at a time. I'm only worried about 3x minus 5x. So as I look at 3x minus 5x, I'm going to do the same thing that I would do over here. I'm going to simplify the left side. 3 minus 5 is negative 2x's. Did I change both sides? No. I combined these to simplify them. I haven't changed this side. These are equivalent. So I don't have to do it to this side. And that's the key. When I don't change the value of this side, I haven't changed the value. It's just an equivalent way of writing it. I don't do anything to the other side. So there's one step. Second step, this is a one-step equation now. Negative 2x equals 12. That's very similar here. So I divide by negative 2 from both sides. That's an inverse operation because now, instead of having negative 2x's, I have a positive x. 12 divided by negative 2 is negative 6. So I had to simplify first. And I'm going to try to bring this a little bit closer because I'm worried that you might not be able to see this on the video. Hopefully that makes it a little easier to see. So we simplified first, and then we solved. So let's do another one. So let's say we've got 5x minus, oh man, Miss Ray just had a brain fart. 12x equals 7. Find the balance point. Draw my inverse line. Okay, so I'm only worried about this side. 5x's minus 12x's. Because I have like terms, I have to combine them first. 5x minus 12x, that's negative 7x. Notice how I draw a line. This comes on down. So now I have negative 7x equals 7. This is an equation that you can solve. I divide both sides by negative 7. Negative divided by a negative is positive. 7 divided by 7 is 1. 7 divided by a negative. So there's one negative, which means my solution is negative. 7 divided by 7 is 1. I'm left over with x equals negative 1. Relatively simple on combining like terms this way. So when you have like variables on the same side, you must combine them first. Listen again. When you have like variables on the same side, combine them first. So try this one on your own. I'm going to write it. You're going to do it. You're going to pause it once I write it down. Solve it. Come back. So let's go. 13x minus 10x equals 30. Go ahead and pause it. So once you've unpaused it, I've got it solved here. Combine like terms on the same side gives me 3x. I didn't do anything to this side, so it comes on down. Divide both sides by 3, x equals 10, and we're nice and easy there. Hopefully you got that one correct. If not, erase it, try it again. So that's one version of two-step equations. Now hear me on this. We will not be doing most of our two-step equations that way yet. We will eventually, but not until module 3. So what are we going to see? Well, we're going to see a lot of equations that look like this. X divided by 4 plus 10 equals 38. So right now, we've got two different terms on the left-hand side. And when I say left-hand side, we find our balance point. We make our inverse operation line. I've got my term x divided by 4, and I've got a term of plus 10. One's a coefficient in a variable. One's a constant. When we are solving a two-step equation, we always want to get rid of the constants. And when I say get rid of, we want to move the constants because we're trying to isolate the variable first. My constant here is positive 10. The inverse of positive 10, good, minus 10. So I subtract 10 from both sides. This is really the additive inverse. Positive 10 minus 10 is 0. So all of this x divided by 4 comes down. Equals 38 minus 10 is 28. This is now division. This is a one-step equation. The inverse of division is multiply. So I'm really multiplying by 4. Wow, that's going to be a big number. I did not mean to do it like this. So this is really 4x divided by 4. The 4 divided by 4 is 1. 1 what? 1x. I didn't really want a big number like this, but again, sleep-deprived brain not really working. 28 multiplied by 4, that gives me 32. Regroup the 3. 4 times 2 is 8. 8 plus 3 is 11. That gives me x equals 112. So, two-step equation. I move my constant first, and then I do multiplication or division. Let's see if that will hold true again. Let's go back. Oh, man. Ouch, 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 ouch. Let's go. 12 plus 3x equals 36. So now I've got 12 plus 3x equals 36. My first step, I find my balance point and I draw my inverse operation line. Do I have a constant and do I have a coefficient? Yeah, constant, coefficient, variable. Our first step is to move the constant. When I say move the constant, we're going to use the inverse operation. The goal is to isolate the variable. This is a positive 12. A lot of you will try to add 12 to that. That just gives you 24. That doesn't help isolate. So if it's a positive 12, the inverse is subtract 12. That leaves me with 0. That gives me 3x equals, that's 4, that's 24. We're back to a one-step equation. This is why math builds on itself. It's very important to know the basics to keep on going. So now I'm going to divide both sides by 3. Because we're always going to finish with multiplication or division. That leaves me with x equals 24 divided by 3 is 8. So yet again, we move the constant with addition or subtraction. We finish solving by multiplying or dividing. Let's do one more. Let's go. 10 equals 3 minus x divided by 2. So we have 10 equals 3 minus x divided by 2. This one is trickier. We find the balance point and we draw our inverse operation line. The goal is to isolate the variable. We have a constant, we have the coefficient, we have the variable. We need to move the constant first. The sign with the 3 is a plus, not this minus, it's a plus. So to get that to equal 0, because the goal is to isolate it, to get rid of this 3, 3 minus 3, well, because that's changing this side, I have to change this side. Now I have 7 equals. Well, a lot of you are going to bring down an x divided by 2. The problem is the sign with it is a negative. I taught you on Thursday that when there's a negative directly out in front, I want it to go with the coefficient in the denominator. So now I have x divided by negative 2. Well, what do we do to get rid of division? What's the inverse of division? Multiply. Well, if it's a negative 2, we have to multiply by negative 2. Hear me out on this. A negative multiplied by a negative is positive. Positive what? Positive 1x. But if I multiplied by negative 2 on this side, which changed it from x divided by negative 2 to just an x, I have to multiply it on the other side. So now I get x equals negative 14. If you leave it like this, that's fine. You could also rewrite it either way. Your homework is just the circled questions. The circled questions that you're doing that you must show all of your work for. You must show all of your work are 1, 2, 3, 4, 7, 10, 14, 15, 16, 17, 20, 21, 22, 24, 27, 28. The sub and or Mrs. Armstrong will give you the worksheet. If you have questions, please make sure you ask. Have a happy, I think, Tuesday. Yay.